China moves 44 billion cubic meters of water every single year, more water than flows through the entire Nile River. It displaced 345,000 people to do it. It carved 3,000 kilometers of canals across a continent, and it gave Beijing total control over the water sources that 2 billion people downstream cannot survive without. By the end of this video, you will understand how the South-to-North Water Diversion Project became the most powerful geographic weapon ever built, and why the countries that depend on those rivers never saw it coming. China is not a wet country. That is the fact that drives everything else. The Yangtze River and the Pearl River drain the south. Together, they carry more than 80% of China's total renewable freshwater. The land is green. The rains come on schedule. The reservoirs fill every year. 800 kilometers to the north, the situation is the opposite. The Yellow River Basin holds less than 8% of China's freshwater, but it feeds the farms and cities that produce more than 40% of the country's grain and house more than 400 million people. This is not a recent problem. It is a structural one. The north has always been drier than the south. The difference is that in 1990, it stopped being manageable. Through the 1990s, the Yellow River began to run dry before reaching the sea. In 1997, it ran dry for 226 days straight. Beijing's water table was dropping by more than 1 meter per year. The city was drilling deeper and deeper into groundwater that had taken thousands of years to accumulate. The wells were running out. The river was not coming back. And northern China was facing a water crisis that no amount of conservation could solve. The geography was the problem. The geography would have to be re-engineered, but the plan had already been written. It had been sitting in a drawer for 50 years. In the summer of 1952, Mao Zedong stood at the edge of the Yellow River and said something no engineer at the time believed was possible. The South has plenty of water. The North lacks it. If we could borrow a little, that would be fine. The idea was simple. The execution was not. Chinese engineers spent the following decades studying what borrowing water would actually require. The numbers came back worse every time. Moving water from the Yangtze Basin north meant crossing mountain ranges, drilling through bedrock, and building canals longer than any infrastructure project in human history. The estimated cost in the 1980s was higher than China's entire annual infrastructure budget. Between 1958 and 1995, 14 engineering teams raised formal objections, not about whether the project should be built, about whether it could be built at all. The project stayed on paper. What changed in 2002 was not the engineering. What changed was that Beijing calculated the cost of not building it. The economic losses from water shortages in northern China had reached $43 billion per year by 2000. The aquifers under the North China Plain were being depleted at a rate hydrologists said would make them unrecoverable within 40 years. The government approved the project in December 2002. Construction began the same month, 50 years after the declaration. The engineers who had raised objections were not consulted on the final design. 3 routes, 3 completely different engineering problems. The eastern route follows the path of the ancient Grand Canal of China, built by imperial labor over 1,400 years ago. It runs 1,156 kilometers from the Yangtze River to Tianjin, moving water north through 23 pumping stations that lift it 65 meters in total elevation. The central route moves differently. A 1,432-kilometer canal carries water from the Danjiangkou Reservoir north to Beijing by gravity alone, following a gradient engineered to the nearest centimeter. Where the canal crosses under the Yellow River, engineers built the longest underwater river crossing tunnel in Asia, carrying water from one river system beneath a second river system to reach a third. The cost human beings paid for this was specific. 345,000 people were relocated for the Danjiangkou Reservoir expansion. Villages that had existed for more than 400 years were submerged. Audit reports from 2012 found that more than 300 million yuan in compensation funds had been misallocated. The people who raised these findings received no response. Engineers responsible for water quality on the eastern route submitted 12 formal reports between 2005 and 2012, warning that industrial pollution would render the water unfit for residential use. The reports were classified. Construction continued on schedule. The project was finished. What it delivered was not exactly what had been planned. The eastern route became operational in 2013, the central route in 2014. Together, they now move 44.8 billion cubic meters of water every year, more than flows through the entire Nile River in a 12-month period. more than 100 times the volume moved annually by all ships through the Panama Canal. Beijing now receives 70% of its drinking water from the central route. Before 2014, the city was consuming its underground reserves at a rate that would have depleted them within 2 decades. That threat is no longer immediate. This is what the project achieved. What it created alongside that achievement was something no planning document had anticipated. Beijing is now structurally dependent on a single corridor for the majority of its water. The central route passes through 4 provinces. Any significant disruption would leave the capital without a functional alternative within 72 hours. The eastern route has operated below capacity since 2013. The water quality warnings dismissed during construction were accurate. Industrial runoff has required repeated suspensions. The route that cost the most delivered the least water. The project solved the problem it was designed to solve. It created a different problem that no one had modeled. And the third route has not been built yet. The Tibetan Plateau is called the Third Pole. It holds more fresh water than anywhere on Earth outside the Arctic and Antarctic. From this plateau, 6 rivers begin their journeys. The Yangtze and Yellow River flow east into China. The Mekong flows south through 5 countries to the sea. The Brahmaputra flows into India and Bangladesh. The Indus into Pakistan. The Salween through Myanmar. Combined, these 6 rivers supply water to approximately 2 billion people. The western route proposes to divert water from the upper Yangtze and upper Yellow River north into the arid interior of China. Construction has not started. The technical challenges are significant. The political implications are larger. India began accelerating dam construction on the Brahmaputra in 2017. By 2024, it had approved 9 major hydroelectric projects on the river. The stated reason is energy generation. The structural reason is that India does not want to depend on river flow that originates on territory it does not control. Neither country has made the water issue explicit in public statements. The competition is already happening, in concrete and steel, not in diplomatic language. There is no international treaty governing the rivers that originate on the Tibetan Plateau. The United Nations Watercourses Convention entered into force in 2014. China has not signed it. India has not signed it. Neither has Pakistan, Myanmar, or Laos. The countries that depend most on these rivers have the least legal standing to challenge what is done to them upstream. The Mekong River Commission exists. It has no enforcement authority. When China built 11 dams on the upper Mekong between 1995 and 2020, it documented the downstream effects. Reduced sediment, disrupted fish migration, altered flood cycles that rice farmers had relied on for generations. Nothing changed. 2 billion people drink from rivers controlled by decisions made in Beijing. They do not know this the way they know the price of electricity. It does not appear on any bill. It does not generate a news alert. But the control is physical. The dams are built. The canals are operational. The western route, when built, will extend that control across all 6 river systems simultaneously. The precedent being established is not about water. It is about whether physical control of a resource, built gradually over decades through infrastructure rather than declaration, constitutes a form of sovereignty that international law has no language to describe. No government has said this out loud. The engineers have. The water still moves. Right now, in a tunnel 60 meters beneath the Yellow River, water from the Yangtze Basin is flowing north toward Beijing. 450 cubic meters per second. Through concrete built to tolerances of less than 2 millimeters, every day since 2014. The people in Beijing who turn on their taps do not think about this. The engineers who built it do. 2 routes operational, 1 not yet begun. A capital city dependent on a single corridor for 70% of its water. 2 billion people downstream of decisions never submitted to any international review. What no model has resolved is whether the pattern holds. The eastern route underperformed because warnings were dismissed. The western route presents warnings that are structurally larger. Whether India, Bangladesh, and the lower Mekong countries can coordinate a response before construction begins is a question with no answer yet. Whether any answer would matter, given that no binding framework exists to enforce it, is a different question. These are not hypothetical scenarios. They are the logical extension of infrastructure already in the ground. The Yellow River still flows east, as it has for 4,000 years. Beneath it, water engineered to flow north passes through in silence. The river does not know the difference. The 2 billion people downstream may not find out until the western route is finished.